Technology lies at the heart of what Hubble is and does. As a result, the developments made in creating and maintaining telescopes like Hubble have influenced fields far beyond astronomy. From industry to medicine, from aerospace to the energy sector, modern-day astronomy has influenced every area of technology.
What practical uses are there for most people, like real-world examples? What do you...
Well, okay, first we do fundamental physics. So that means that whatever we do, it's not to have an application like tomorrow. And something that has a direct application is general relativity. Remember Einstein, 1916, just 100 years ago, he thought general relativity. And for years it was useless. I mean, useless for normal people.
For normal people.
Now, nowadays, everybody uses it daily.
Yeah, and they would not believe where, right? Because they carry it in
GPS,
their own
GPS in your cell phone, that is a direct application of general relativity. More precisely, it would not work without general relativity.
Hubble is a sophisticated instrument, setting a gold standard amongst observatories. It required cutting-edge technology to bring it into existence in the first place, and continual improvements and upgrades, including 5 servicing missions, got it to where it is today. It is not surprising, then, that many technologies originally developed for Hubble and other astronomical instruments have found their way into other areas. Astronomical imaging technologies made a huge impact on medical equipment. Some of it, like CCD and CMOS detectors, also made it into everyday life. These electronic chips convert photons into an electrical charge, allowing cameras to respond to light with incredible efficiency. CCDs are crucial to Hubble. Its advanced camera for surveys uses a CCD camera to capture images such as the Hubble Ultra Deep Field, the deepest visible light image of the cosmos ever obtained. The decision to use supersensitive CCD technology on Hubble played a huge part in the improvement and popularization of these detectors. Similar ones have since found their way into personal cameras, webcams, and mobile phones.
By the way, also just 1 century ago there was quantum physics, complete revolution in the way we imagined the world. And without quantum physics, a cell phone wouldn't work either.
As familiar to us as our smartphones and digital cameras are our GPS gadgets. Through a system of satellites operated by the US military, car drivers and smartphone users can pinpoint their location at any given time. GPS satellites use very bright and very distant astronomical objects to help them determine positions with high accuracy. Creating accurate maps of these bright objects, known as quasars, required close collaboration between the developers and astronomy. The European Union, in collaboration with ESA, is currently creating its own pure civilian satellite navigation system, Galileo, which will begin working at the end of 2016. It is not astronomy's hardware that has got it noticed in the wider world of technology. Hubble's instruments would be much less useful without the right software to analyze the data they collect. This software has been created using special programming languages. Interactive Data Language, or IDL for short, is one such programming language. Today, it is popularly used in medical imaging and atmospheric physics. But the first IDL programs were used to analyze astronomical data, and today astronomers still account for many new programs. IDL is not the only thing that medicine and astronomy have in common. Far from it.
You know, there's visible light, there's radio, there's infrared, and these are all electromagnetic waves that astronomers like to use to observe the universe. But at some point, the X-ray was just missing. So an astronomer said, okay, we really need to do something about it. And he developed the technology to observe the sky in the X-rays. So he got a Nobel Prize, which was nice. And we got the technology. So now we are all using it every day whenever we go through an airport for the security or if we go to the hospital. So this is an example of technology that is used on a daily basis, thanks to astronomy.
The advanced imaging techniques used by Hubble to see deep into space have now been used to allow doctors to visualize breast tissue without surgery. Software developed for processing satellite pictures from ESA has been adapted to detect signs of Alzheimer's disease in magnetic resonance imaging scans. And these scanners, along with many more used in the medical field, have benefited from the advancements to imaging technology brought about by creating telescopes like Hubble.
The stars twinkle, and that's a very big problem for the astronomers. In fact, the stars do not really twinkle. The problem is our atmosphere because it moves around. And in order to correct for the movement of atmosphere, astronomers come up with a very smart idea called an adaptive optics. And the idea is either you pick a very bright natural star or you use a very powerful laser and shoot to create a laser guide star. So the idea would be, you know how the perfect star supposed to look like, and then you measure that either laser guide star or natural bright star in your telescope, and by comparing how these two look like and doing a bunch of complicated math, you can figure out an algorithm to correct for your image.
And this technology has been transported into a medical application, hasn't it?
Indeed. So they have developed the laser operations, and actually, in fact, I had such operations, which is called the LASIK, and the idea is very similar. Basically, they figure out what is the perfect eyeball shape supposed to look like, and they use the laser to help correct for that. And with that, you will be able to see the world much clearly and nicer.
This is just the tip of the iceberg. Technology originally designed to explore the universe has contributed in hundreds of ways to our daily lives and has also fostered international collaboration. Whilst the payoff in our day-to-day lives might not always be immediate, it is very real. From contributing to a diverse range of fields through technology transfer to changing our perspective on the universe we live in, astronomy continues to play a bigger part in our daily lives than we realize.
We value a lot old observations. We want to keep them forever, because if you do an observation, it will never be redone because the sky is changing. So we have observations that are really old, like 10, 20, 50, 100 years. So we have a image format fits. It's not of very widespread use, but it's extremely standard.
So
everybody
that's
uses
something
it.
like JPEG that most people know, or
it's
GIF,
it's like JPEG, but everything is described in the file. So if you just get the file, you know how you have to read it. And now some archiving for other fields than astronomy use it too, like old libraries. The Vatican library is using our astronomical format, and you know they have long term in mind. So all the digitization of the Vatican archive is now being done in that FITS format, which is universal for all astronomers. So think, I could receive a tape or a CD or an image that was taken in the United States 30 years ago and share it with a Russian colleague. No problem of proprietary formats, no problem of version, it just works, it's just standard magic.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.